The topic is double integrals in polar coordinates. So let's do this example. Find the volume of the solid bounded by the plane z equals 0 and the parabola with z equals 4 minus x squared minus y squared. Alright, so let's draw this, let's graph the surface. We know this goes from 4, right? The parabola width will be if you let z equals 0, you're gonna get 4 minus x squared minus y squared equals 0. So x squared plus y squared equals 4. That would be the projection on the xy plane. In other words, you're gonna have a disk with radius 2. So this is the projection. In other words, here it's gonna be alright. So how do we do the volume? So if we look at the definition, the double integral over d, our d is right there, the disk of f of xy dA. In our case, well, actually the volume, we're looking for the volume. Volume will be just the double integral over d of f of xy dA, because f of xy is above the xy plane. So that would be equal, we want the theta to go from alpha beta, so the theta here will have to go from 0 to 2 pi. Alright, so 0 to 2 pi, and the radius has to go from 0 to 1, from 0 to 2, sorry, 0 to 2, and our function is 4 minus x squared minus y squared, or let me rewrite it, x squared plus y squared, which is just r squared. So we're replacing each x by r cosine theta and each y by r sine theta. So in other words, we're using x squared plus y squared equal r squared. Right? Let me rewrite it. This is equal 4 minus x squared plus y squared, which is 4 minus r squared. And don't forget this r, this is an r, and then this dr d theta. So the volume will be equal, we're going from 0 to 2 pi, we're going to do this integral first, so I'm going to distribute, so it'll be 4r minus r3 dr d theta. Now we're taking, well, don't forget, this is going to be 0 to 2. Again, we're going from 0 to 2 pi. This integral will be 4r squared over 2 minus r4 over 4, and that's between 0 and 2 d theta. Let me simplify this. 4 divided by 2, you'll get a 2. So 0 to 2 pi 2r squared minus 1 over 4 r4 between 0 and 2 d theta. Now plug the 2, you get 2 times 2 squared minus 1 over 4, 2 to the 4th. Plug a 0, you'll get a 0. And all that will be 0 to 2 pi d theta. Now this is going to be 4 times 2, 8. So 8 minus 16 over 4 is 4. D theta from 0 to 2 pi. Integral from 0 to pi, 8 minus 4 is 4 d theta, which is equal 4 theta between 0 and 2 pi. Plug in the 2 pi and a 0, you'll get 8 pi. And that's it for this example.